All right, guys, so today we're going to continue in lesson 8.2 and build on what we talked about in our last lesson, which is where we were talking about how an equation that has two variables has more than one solution. In fact, it has an infinite amount of solutions, but not everything. So we looked at equations and we checked whether different things were the solutions or not. We also looked at an equation and I asked you to give 5 possible solutions. But again, there's an infinite amount. And so we have a problem, like we talked about, where we can't say it's everything because it's not everything is the solution, but we also can't list all of the solutions because there's an infinite amount. And so that's what we're going to tackle in today's lesson is how do we solve that problem. All right, so let's start by filling in some blanks here. The graph of an equation in two variables is the set of points in a coordinate plane that represents all of the solutions of an equation. An equation whose graph is a line, we're going to be looking at straight lines today, is called a linear equation. So everything we graph in today's lesson is going to be a straight line. All right, so we're going to start with the most basic of equations with two variables, and that is y equals x. Okay, so y equals x has an infinite amount of solutions, but not everything. So we are going to make a table to represent some of those solutions. So I can pick values for x, and we talked about this a little bit in our last lesson. I can pick x to be whatever I want it to be. So x could be 219. It's just, why would you pick something that big if you don't have to? And it's going to be even harder when we try to start graphing it if you pick big numbers. So I'm going to tell you that you need to pick at least 5 numbers, and you need to pick some positive numbers and some negative numbers. So most of the time, the easiest ones to pick will be -2, -1, 0, 1, and 2. Now there's more space in your table. You could continue to pick more. Again, there's an infinite amount of things that you could pick, but I'm going to tell you you only have to pick 5. Normally we'd show our work here, except here there's not really any work to show because if x is -2, y is -2. If x is -1, y is -1. If x is 0, y is 0. If x is 1, y is 1. And if x is 2, y is 2. Again, this is a very basic, simple equation, so there's not much work to show. Now, we can take this information from the table and write them as ordered pairs. So we have -2, -2. We have -1, -1. We have 0, 0, 1, 1, and 2, 2. And then we can put those ordered pairs on the graph. Okay, this is what we did the other day when we talked about relations. We talked about how there's multiple ways we can represent a relation. We can look at it as a table, as ordered pairs, and on a graph. And so that's what we're going to do today is we have the table, then the ordered pairs. Now we're going to put these on a graph. So I'm going to plot the point -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. And what you should notice is that those points make a straight line. Now, on my graph now, I have 5 possible solutions to this equation. But remember, how many solutions are there? There's an infinite amount. And so to show all of the possible solutions, I need to draw a line and make sure your line is straight. In Notability, which I'm not using right now, but if you hold down as you make a line, it will turn your line in straight. I can help you with that later if you need, but if you draw a line and keep holding it, it will straighten it for you. But your line should be straight, and you want to put arrows at the end of each side of your line to show that this line goes on forever. Now, what we have shown here, guys, is that every single point on this line is a solution to the equation. And think about that. Here we have like 4, 4. Well, we know that would be a solution. And even here we have like 1.5, 1.5. Well, that would also be a solution. And -5, -5, that would also be a solution. So everything on the line is a solution. And every point that's not on the line, all these out here, those are not solutions to this equation. And so we've now solved our problem, that we have shown all of the possible solutions. We've shown how it's infinite because we put arrows on both sides, but it's not everything. And so we're saying it's not everything, it's just the points on this line. Now, because this line is the most basic equation, and therefore the most basic graph, y equals x, it doesn't get any simpler than that when we have two variables, we have a special name for this equation. So the equation y equals x is called the parent function. And we are going to be referring back to the parent function over and over again when we graph other lines, okay? So let's go ahead and head over to the next page. All right, so the next equation that we're gonna graph is y equals 2x. So just a little bit different than the one we just did. So we need to make our x-y chart, which is very simple. Just make a little t-chart with an x and a y. You get to pick values for x. Again, you can pick anything you want, but you need to pick at least 5 things, some positive, some negative. So the easiest things to pick would be -2, -1, 0, 1, and 2. And now here you do need to show your work. I'm going to tell you that you need to show your work for plugging in at least 3 of the points. If after 3 you can do it in your head or you start seeing a pattern, then you can stop showing your work. But you need to show it for at least 3. So here we go. I have y equals 2, and for x I'm going to first plug in -2. Well, 2 times -2 is -4. So when x is -2, y is -4. Then I'm going to move to the next one. Y equals 2 times, and this time I'm going to plug in -1. When x is -1, y is -2. Then I'm going to plug in 0. So y equals 2 times 0. When x is 0, y is also 0. And now, again, you can start doing it in your head, or you can start seeing a pattern. So when x is 1, y is 2. When x is 2, y is 4. All right, now I'm also going to let you skip the step where you write them out as ordered pairs. If that still helps you, then by all means go for it, but I think most of you can go straight from the table to the graph without writing them out as ordered pairs, so I'm going to let you skip that step. So now we're going to put these points on the graph. So I have -2, -4, then I have -1, -2, 0, 0, 1, 2, and 2, 4. Again, here are 5 solutions on my graph. There's an infinite amount of solutions, so I can't stop with just those 5. I need to use these 5 to help me make the line. Make your line nice and long and straight. Put arrows on the end to show that it goes on forever. And again, I have now shown all of the solutions to y equals 2x. All right, so in this box now, it wants you to compare this graph to the parent function. In other words, how is it different and the same as the one we did previously, the parent function? All right, well, let me show you on this graph again the parent function. Remember, the parent function was y equals x. So that goes right through there. 1, 1, 2, 2, 3, 3, just like that, okay? That was the parent function, that green line that I just graphed. So as we look at the red line, y equals 2x, we talk about how is it different. What I hope you see is that the red line is steeper than the parent function. And think about this like the side of a hill. I'm gonna make that red so it's easier for you to see. Think about it like the side of the hill. If you were hiking or skiing or sledding down this hill, hopefully you can see that that red hill is steeper than the green hill. And so we would say that line is steeper than the parent function. All right, now, this line is not shifted. And when we talk about shifted, we're going to be talking about where our line crosses the y-axis. For now, we can see that they both cross at the origin, so it's not shifted. We'll dive into that one deeper in a few more examples. This line is also what we call rising. and the parent function is also rising. When we talk about whether a line rises or falls, we are following the line from left to right, just like we read a book on a page. So notice the parent function starts, if we start from the left and move to the right, we see that that line points up. So we would say it's rising. As we look at the line we just graphed, y equals 2x, and we start from the left and move to the right, we see it also points up and therefore is also rising. So this line rises. All right, let's move on to the next one. Here we have the equation y equals 5x. Okay, so again, pretty similar, but we've got a new coefficient there. So we're going to make our xy chart, and I'm going to plug in the same things as always, -2, -1, 0, 1, and 2. All right, so we need to show my work for at least 3. So I have y equals 5 times -2 first. So when x is -2, y is -10. All right, now I'm going to plug in -1. So I have 5 times -1. So when x is -1, y is -5. And then I'm going to plug in 0. So I have 5 times 0, which is 0. So when x is 0, y is 0. And again, after you've done 3 showing your work, you can start doing it in your head. And so when I plug in 1, when x is 1, y is 5. When I plug in 2, y is 10. All right, now let's put these points on the graph. All right, well, the first point is -2, -10. That doesn't fit on my graph. So I could make a new graph or extend my graph. But for right now, let's just go ahead and skip it. Let's go on to the next one. We have -1, -5. Okay, that does fit on my graph. And 0, 0 fits on there. And 1, 5 fits on there. But the last one also, 2, 10 does not. All right, well, here's the deal. Remember, the points are not your answer. The line is your answer. The points help you make the line, but do you have enough information right now to make your line? You do. So it's okay that you can't fit all 5 points on there. As long as you have enough information to make your line, you're good. So I'm going to go ahead and use these 3 points to make the line that represents all of the possible solutions. Again, make your line nice and straight, which Notability makes easier for you. Put arrows on the end. All right, let me again draw for you what the parent function looks like. So it's on that same graph to compare. If it helps you, you can draw in the parent function, but you don't have to. Okay, so how does this compare? Well, hopefully you see this line is even steeper than the last one, but it is definitely steeper than the parent function. That would be quite a hill to hike or ski down. So that one's definitely steeper. This one is also not shifted, and again, we'll get into that more in future examples, but we see it crosses at the same spot. And this one is also rising. And again, we know that because the parent function, when we follow from left to right, points up, and this one, when we follow from left to right, also points up. So it is also rising. All right, let's go on to the next one. Okay, this equation is y equals -2x. So now we're throwing in a negative sign there. All right, let's see what that does to my graph. So I make my xy chart, and I'm going to plug in -2, -1, 0, 1, and 2 again. Show my work for 3. So I have y equals -2, and I'm going to plug in -2. So that gives me +4. When x is -2, y is +4. All right, now I'm going to plug in -1. So -2 times -1 is +2. Then I'm going to plug in 0, and -2 times 0 is 0. Then I can start doing them in my head. So when x is 1, y is -2, and when x is 2, y is -4. All right, so let's plot these points. We've got -2, 4, -1, 2, 0, 0, 1, -2, 2, -4. So this time all 5 points fit on, which is great. Obviously, the more points, the better. It's just we only need a couple to make our line, all right? Also, guys, I hope this is obvious, but if you plot your points and they don't make a straight line, you know you have done something wrong. They have to make a straight line. It's a good little check to make sure you're at least on the right track. Okay, now let's compare it to the parent function. So I'll draw again the parent function on there for you. All right, and you'll notice right away this one's looking a little different. So first of all, when we talk about its steepness, we would say that this line is steeper than the parent function. It's pointing the other way, which we'll get to in just a minute, but it is steeper than the parent function. And if it really helps you, you could always, guys, draw, you know, the parent function going the other way too, if that helps you compare whether it's steeper or not. Okay, so this one is steeper. It is still not shifted. But this is where it gets a little different. So remember, we've talked about the parent function, when we follow it from left to right, it points up. Well, notice on this one, when you follow it from left to right, it points down. So this line is falling. The last two we did were both rising because they also pointed up from left to right. This one points down, and so we say it is a falling line. All right. That's where we're going to stop for today. We're going to continue to look at more and more examples the next time we're in class together. But for now, hopefully you're starting to get just a little bit of an idea of how we can use a graph to show the solutions to an equation. Because again, each equation has an infinite amount of solutions, but not everything. All right, have a great rest of your day. Good work today.